So this function looks a little different, and I want to address that first. So that's the standard form of a quadratic equation, and we have the n squared part, and we have the constant, but we don't have the bx. We don't have that middle term. We can still solve for the zeros of the function, but I want to look at the graph first because it is different. So when I look at the graph, I notice that it's directly in the middle of the y-axis. The y-axis is actually the axis of symmetry, cutting it in half, and that the y-intercept is at -64, just as it should be, because the c, which is our constant, or our y-intercept, is -64. So I guess we can conclude when there's no b or middle term that the function doesn't move left or right. It's just going to be directly in the middle of the graph. So then how would we find the zeros of this graph? Well, we don't have any factors, so we're just going to solve it the way it is. So if we did do that, we would add 64 to both sides, and we would get n squared equals 64. Well, we learned back in Unit 1 that the opposite operation for a square is a square root, right? A square and a square root, those are opposite. So if we want to get n by itself, we have to square root both sides. So when we do that, when we square root something, we're allowed to circle groups of 2 and remove 1. And that's how we simplify it. So technically, this is now just n. With the 64, it's the same thing. But in this case, we could be circling 2 8s, right? Because 8 times 8 is positive 64. So 8 is an answer. But we could also be looking at 2 negative 8s, because a negative times a negative is still a positive 64, right? So for this example, we have 2 answers, just like we always do, but you have to consider what creates positive 64. In this case, positive 8 times positive 8, or negative 8 times negative 8. So that means the zeros of our function are -8, 0, and 8, 0. Negative is smaller, positive is bigger, and it's going to be on both sides, right? We have -8 over here, and then we have +8 on the other side.